In this video, we're going to look at establishing trigonometric identities. Suppose I ask you to establish the following identity. 1 minus cosine squared negative theta equals sine squared theta. First, you need to make sure that you understand the even-odd identities. Let's take a look at those. For our even-odd identities, we have sine of negative theta equals negative sine theta, cosine of negative theta equals cosine theta, tangent of negative theta equals negative tangent of theta, cosecant of theta equals negative cosecant theta. Then we have secant negative theta equals secant theta, and cotangent of negative theta equals negative cotangent theta. Note that in the cases where we have a negative angle, cosine negative theta, we have positive cosine theta as its identity, and for secant negative theta, it's equal to positive secant theta. The remaining cases are negative. You'll also want to make sure that you know your Pythagorean identities. For this particular case. The Pythagorean identities are sine squared theta plus cosine squared theta equals 1. This is perhaps the most well-known and most useful of the Pythagorean identities. Then we have tangent squared theta plus 1 equals secant theta squared. And we have cotangent squared theta plus 1 equals cosecant squared theta. So these are Pythagorean identities. To establish our identity, we'll want to start with the most complicated side of our expression. In this case, that's the left. 1 minus cosine squared of negative theta is equal to 1 minus cosine theta squared. I know this from my even-odd identities. We can rewrite this as 1 minus cosine squared theta. Now, let's consider the Pythagorean identity cosine squared theta plus sine squared theta equals 1. If we rewrite this Pythagorean identity by subtracting cosine squared theta from both sides, it's clear that sine squared of theta equals 1 minus cosine squared theta, which is the expression we have here. So I know that 1 minus cosine squared theta is equal to sine squared theta, and this is the identity that we wish to establish. Therefore, we're finished. Let's take a look at one more example. Suppose I have 1 plus sine of theta times 1 minus sine of theta is equal to cosine squared theta. In general, when we're establishing an identity, we start with the more complicated side of our expression. So we're going to work the left-hand side and try to get it to match the right. I'll start by foiling the left side of our equation. So I have 1 times 1, 1 times negative sine squared, or negative sine theta rather, sine of theta times 1, and negative sine squared theta. The two middle terms cancel out, and I'm left with 1 minus sine squared theta. If we consider our Pythagorean identities, we know that one of them is sine squared theta plus cosine squared theta equals 1. As I said earlier, this may be possibly the most frequently used Pythagorean identity. It's certainly very useful. We can rewrite it by subtracting sine squared theta from both sides, which gives us cosine squared theta equals 1 minus sine squared theta. And we've established our identity, because we know that 1 minus sine squared of theta is equal to cosine squared theta. So hopefully you found these two examples helpful. We'll see you next time.